are going to start the 8th chapter, that is your central processing unit. In your course, there are the 3 sections, 8.4, 8.5, and partially introductory part is there from the 8.8. So, in this class, I would like to focus on addressing modes. That is related to the section 8.5, and it is extremely important topic from the exam point of view. What actually is the addressing mode? You already have done the instruction format in 5th chapter. The instruction format is basically the layout of an instruction, the binary coded format of the instruction, how it is stored in the instruction register, that we already have done in the previous classes. It essentially consists of 2 parts. This is the structure of your instruction format. It essentially consists of two components. One is your OP code and another is the address part. OP code is the operation part of the instruction, and address is basically the operand over which the instruction will be operated upon. For example, this is the example of one of the instruction, add 457. So how will it be represented when it will be stored in the instruction register in the binary form? So it will be represented in the binary form consisting of essentially 2 components, OP code and address. This is your add will be considered as your OP code, and 457 is the address of the operand. So addition will be basically addition will require the 2 operands. One operand we are assuming that is stored in the accumulator register, and another operand will be collected from the memory that is basically addressed by this address 457. That is specified as the part of your instruction. I already told you that all the instruction, I already told you in the previous classes that a program consists of a number of instructions, and the program along with all the data or the operand are being stored in the main memory. So whenever the CPU has to execute the entire program, it will execute it by instruction. So first of all, it will go through the instruction cycle to execute one instruction. It will apply a number of steps or the phases on that for the execution of that instruction. Then control will come to the next instruction and so on. So instruction by instruction, the entire program will be executed, and where initially the program is resided, the instruction is resided, or the entire program is resided in the main memory, as well as all the data. Like we are going to talk about the addition of 2 numbers. So we have a program consisting of a number of instructions that will be resided in the memory, as well as 2 operands. One operand we are assuming here will be stored in accumulator register, and another operand will be stored in the memory. And in order to execute this instruction addition, the operand will be brought from the memory, and the way it is brought from the memory, that is called as your addressing mode. How the mode, this is the mode that facilitates to address the data which is stored in the memory, so that ultimately the instruction may be performed. Fine, this is the introductory part of your addressing mode. We have a varieties of addressing modes, so that in a different manner the data may be brought from the memory, and ultimately the instruction may be operated upon that data in order to achieve the final output. Fine, now we are going to consider the various kinds of the addressing modes. Earlier I told you that instruction format essentially consists of 2 components. One is the OP code. OP code is the operation code. Operation code is basically like add is the example of your operation code. Add, similarly the subtract, multiply, and different kinds of the operations may be there. Similarly, I told you that address should be there. Address from where actually the data will be brought from the memory. So that is called as your address part. But it's not always fixed that there will be the 2 components. There may be 2 or more components depending on the nature of the addressing modes. So we can have this kind of the instruction format as well. This instruction format is consisting of 3 components. It is consisting of mode bit, OP code, and address. You will recall that in the 5th chapter, we already have done with direct address instruction as well as the indirect address instruction. In case of direct address, those again were the 2 kinds of your addressing modes. But in this chapter, we are going to study many more kinds of the addressing modes other than direct and indirect address instructions. If you recall all the concepts, that direct address instruction, in case of the instruction format of the direct address instruction, this mode bit was of the capacity 1. That we called it as I. We indicated by I. Whenever a value of I is 0, that means it will refer to the direct address instruction. As in case my value of mode bit is 1, it will refer to the indirect address instruction. Fine. So similarly, in case of the other kinds of the addressing modes, we will be having the different kinds of the instruction format consisting of various kinds of the components. Now we switch to the next slide. It is basically this is the same kind of the example that is mentioned in the 5th chapter. It says that it is the example, it is a direct instruction. It consists of, this is a memory. This memory consists of a number of instructions, as well as in the down portion, somewhere in some of the locations, the operands or the data are being stored at some specific location. So this one at a time, we are going to talk about one instruction. This is one instruction. And this instruction, this memory, entire memory is divided into a number of words. And presently, this one instruction is stored in the capacity of one word. Each and every word again is consisting of some kind of address in the memory. Like 22. 22 is the address of a program counter. It is basically, it is the address of the word actually where internally the instruction is being stored in the memory. Fine. So this 22 is the address of this specific word where this instruction that consists of 3 components is being stored. And this instruction is consisting of 3 components. 0 means it is a direct address instruction. ADD is the OP code. 457 is the address of the operand where ultimately this addition will be performed. Addition, whenever this add operation will be performed, it will do the addition of 2 operand. One operand it will pick up from this 457th location in the memory, and another operand will be brought from the accumulator register that already being stored, we are assuming, and ultimately both the contents will be added and the result will be stored back to the accumulator register. This is the example of a direct addressing mode, you can see. Fine. And similarly, this is the screenshot again taken from the 5th chapter. It is the example of your indirect address instruction. Again, one specifies the indirect addressing mode. Again, the various addresses of these different words are given. Indirect addressing mode says that this address 300, the control will go to this address part, and wherever ultimately this 1350 is mentioned, that is not the value of the operand. This is again, this is, yes, Shubham. You do have some kind of the doubt? Hello? Yes, Shubham? Yes, Shubham? Yes, Shubham? Are you having some kind of a doubt? Tell me. Anyway, we'll discuss the doubts later on in the end of the session. Now, this 300 again, the control will go to the 300 location. And here again, the address, one mode address is located. Again, we will, in the next attempt, we will be able to collect the contents, or the CPU will be able to collect the contents of the operand from the memory. Means indirectly, it's going to go to the value of the operand in 2 attempts. That is the example of your indirect address. Again, it is one of the kind of a addressing mode. Other than these two, we do have a different kinds of the addressing modes. We'll go one by one. We'll discuss one by one. First one is the implied mode. Implied mode says that operands are specified implicitly in the instruction itself. Means there is no need to explicitly specify the address or value of the operand. It's implicitly specified in the definition of the instruction. The example of the implied mode is increment accumulator or CMA. CMA says that complement accumulator. So as and when the name comes out, it automatically is implied that accumulator will be incremented by 1 and operand is being specified in the accumulator register. There is no need to bring the value of the operand from the some location of the memory. So this is one of the example of the implied mode. Now we come to the immediate mode. In the immediate mode, this is another kind of the addressing mode. The immediate mode says that the address field contains the operand itself instead of the address of the operand. Again in front of us, this is the instruction format, or the instruction is there, which whenever is brought from the memory and stored in the instruction register, this will be the format it will appear to us. It is consisting of add, and another part is not the address, rather the operand itself. So in case of immediate mode, operand in place of address is available there in the instruction register. So the address field itself works as the value of the operand. So value of operand in this case will be 50. It is not working as an address. It is working as the final value of the operand. And now next is the register mode. What is the definition of the register mode? It says that the address field, because we are here, we are going to talk about two fields. One is the OP code field, another is the address field. It says that the address field contains the name or the unique number of a CPU register which contains the operand. This is the definition of a register mode. It says that ultimately what is our purpose? Our purpose is to bring the data from the memory from a specific location. And this, if we are going to follow this register mode, so this register mode says that in case of the address part of the instruction, there is the name of a register is specified or the unique number of the register is specified. And further, if control goes to that kind of register, whichever the value of that register is lying, that will work as a value of the operand. So finally, how the value of operand is collected? This value 50 will work as the value of the operand in case of your register mode. Fine. This is the definition of register mode. And later on, I will illustrate all these concepts by taking one example. It will be more clear to you. Now we are coming to register indirect mode. What is the definition of the register indirect mode? It says that the address field contains the address of a register which holds the memory address of the operand. It's a similar kind of the indirect address mode earlier we have studied. That was a memory reference addressing mode, but rather we can call it as a register reference addressing mode. It says that the address field of the register does not consist of the value of the operand. Rather, it consists of a register. The register further consists of the value of the address of the memory, where in the memory actually the data is being stored. It says that. Again, I will take one example to illustrate this concept. Now we are coming to the next definition of the addressing mode. This is your register indirect mode. The same register indirect mode that earlier we have decided. This is the example. What I am repeating the definition of the register indirect mode. It says that the address field of your instruction contains the name or the unique number of, like here in this case is the R1. R1 is the register. So this instruction consists of address part consists of a name of the register R1, which further this R1 holds the value of the address of some location in the memory, where ultimately this data 50 is stored in the memory. So ultimately, which data will be brought from the memory? This 50 will be brought. How will it be brought? It will be brought, first the control will go to the instruction register. It will go to the address part. Here it will find out the name of the register. The control will go to that specific register. Then it will pick up the value of 250. This 250 is nothing but the address of some of the memory location in the memory, and ultimately from this 250th location, this 50 value will be brought, and ultimately this add instruction will be operated upon this 50 and some of the another operand stored in the accumulator register. So this way this instruction will be performed as per this kind of a addressing mode. Fine. Now we are coming to next kind of addressing mode. That is your auto increment or auto decrement. See carefully. It is similar to the register indirect mode that earlier we have done. Means we need to have some kind of a register in the address part. Further register will consist of some kind of address of the memory location. Further, what is the additional feature in this auto increment and decrement? It says that similar to the register indirect mode, except that the value of the register is incremented or decremented after or before. Specifically, you have to focus on these two words. After or before, it has been used to access memory, usually used to refer to a table of data. I will explain this again further when an example will come. It basically says that In case of auto increment, it is similar kind of the register mode as a register indirect mode. The control will go to the address part of the instruction. In address part, name of the register is there. Control will go to the register and value of that register. Again, it will locate the data from the memory, and once it has been used, the value has been used. Afterwards, the value of that register will be incremented by 1. So it is saying the same thing in the definition. If you read out the definition carefully, it is saying the same thing. Once its value has been utilized, then only the value of the register is incremented once its value has been utilized. But in case of your auto decrement, its value will be utilized before its value will be decremented before its value has been utilized. This is the difference. This difference I will illustrate you further. There will be an example, then you will get then the concepts will be more clearer. Now I am coming to the direct addressing mode that you already have done with. I already have shown you 2 slides of this. That directly the address field contains the memory address of the operand directly in order to locate the value of operand. In case of indirect addressing mode, again you already have done with this, and the definition says that the address field contains the address of the memory location that contains the operand. Means in case of indirect addressing mode, indirectly you are going to get access to the data stored in the memory by after the 2 memory reference instruction. This is the example of direct. I already have shown you. You need to go to 457th location in order to pick up the value of operand. Directly you are going to get the value of operand. And in case of your indirect, first you are going to at 300th location, further you are going to get again the value of operand, value of address in order to get the final value of operand. See, so you have to remember one thing. The final target address of the operand is called as the effective address. So we are having the effective address, or the effective address is the final address where actually the operand is being stored in the memory. So in case of indirect address, the value of effective address will be 1350, and in case of previous slide, the value of effective address will be, its value will be 457. Now next type of the addressing mode is relative addressing mode. What is the definition of the relative addressing mode? It says that the address of the program counter for the next instruction is added to the address field to get the address of the operand. So what it says that, say we are having this instruction add 300. Add is the OP code, 300 is the address. It says that how to locate the value of the operand, or what is the formula to locate the value of the effective address. Once we are being able to locate the effective address, it will be very easy to find out the data. So how to locate we will get to know how actually the data is lying in the memory once we are being able to find out the value of effective address. So as per the definition of the relative addressing mode, what is the formula of effective address? It says that address part, the value of the address of the instruction, means this 300 is added to the value of PC plus 1. PC is the program counter. What is the value of PC plus 1? PC is presently, it's going to point to the recent instruction, and PC plus 1 will point to the next instruction, the address of which will be 201. So the address of the next instruction, that is 201, is added to the address part in order to get the value of your effective address. So what will be the value of effective address? It will be 501. And what will be the final value of operand? It will be 50. So from this 50 ultimately will be used in the addition, in the add instruction. So this is the way how we find out the value of effective address in the relative addressing mode. Next types of the addressing modes are there. Indexed addressing modes. How to find out how to find out the value of the effective address in case of your indexed addressing mode? The definition given is the content of an indexed register is added to the address part of the instruction in order to obtain the effective address. So we are assuming that some kind of the index register will be given. It's a kind of a displacement addressing modes. These 3 kinds of the addressing modes, which are those 3: index addressing mode, base register addressing mode, and the previous one, the relative addressing mode. These are kinds of the displacement addressing modes. Means you are having a kind of a base register, and fixed point from there by adding some kind of offset value, you are going to locate the value of the final effective address. So this is the index. This is the formula to find out the effective address. Content of index register you need to add with the value of the address. Again, I will illustrate it with the help of the example in the next slide. And next addressing mode is base register addressing mode. It says that the content of a base register is added to the address part of the instruction in order to contain the effective address. So what is the formula to find out the value of effective address? The contents of base register are added to the value of the address part of the instruction in order to get the value of effective address. Fine. Now this is an example. I think we are running out of the time and we'll have to start a new meeting. So I'm just stopping this meeting. We'll restart it. Am I audible to you?
Yes, ma'am. दो बच्चों के error थे.
चलो anyway I would like to continue. ठीक है? This is the example. This is example of addressing mode. Addressing mode. Here we are given a memory. This is the memory is given. It is a solved example in your book. And based on this example, there are the many questions in the back exercise. You are supposed to solve all those questions, and we'll discuss all those questions one by one. So this is a memory. This is memory. Memory consists of a number of memory. Please, no talking, please. Listen quietly. The memory consists of a number of words, and then these are the various address given to the different words of the memory. The very first word is stored at 200 location, then 201 location, then 202 location. No talking, please. No talking, please. So here, what kind of instruction is given? Load to AC. Earlier we have done the add instruction, but this is a load to AC. Load to AC instruction. What is the function of the load to AC? It says that the sum of the operand will be brought from the memory and it will be loaded to AC. So what kind of a question will come to you in front of you? If this given question is there, like this right hand portion as well as this addressing these registers, values of different registers are given, you will be asked to specify the effective address as well as content of AC when in case of these different kinds of the addressing modes. You will be asked these kind of the question. Like in this red, the red color, you can view all these kinds of the addressing mode, and the right hand side portion you will have to find out. Based on this given data, you are given this memory. It will be given in your question, and similarly values of all registers will be given in a question, and you have to find out the value of effective address and the content of AC in case of different kinds of the addressing modes. We will start one by one. Here you can view that your instruction, I told you that instruction consists of 3 parts generally, 2 or 3 parts, but here in this case it is consisting of 3 parts. What are those parts? One is the OP code. What is the OP code in this example? Load to AC and load to AC, and this mode bit is to specify the mode bit whether the instruction is direct or indirect, and similarly the third component is the address. Now here you can observe that your instruction, which is consisting of 3 components, is not stored in the capacity of 1 word, rather it is stored in the capacity of 2 words. Means 2 components are stored at the location 200, and the next component, that is address field, that is stored at 201 location. So here it is going to occupy 2 words capacity in the memory. Now, based on this information, so we will start from the very first addressing mode, that is your direct address. What is the definition of the direct address? In case of direct address, we have to find out the value of effective address. So what will be the effective address? Ultimately load to AC. So in address part 500 is there. We need to go to the 500 to locate the value of the operand. At the 500 location, what will be the value of the operand? It is 800. So as per the definition of the OP code, what is the OP code? It says that load to AC. Whichever the operand is lying at this address 500 location, it will be loaded to AC. So ultimately what will be the contents of AC? It will become as 800. So this is the answer of your very first question. In case the instruction is direct address, so what will be the effective address? The value of effective address will be 500, and value of contents of AC will be your, you need to go to 500 and the value is coming out as 800. So value of content of AC will be 800. So this is the answer of your effective address as well as content of AC. In case we are going to talk about very first instruction, very first addressing mode, that is your direct address. Similarly, by going by the definition of addressing mode and by going by the given information, we have to find out the effective address as well as the content of AC. Now we need to consider, we are coming to next kind of addressing mode, that is what immediate operand. Again, in case of immediate operand, what two components we have to find out? One, we have to find out the effective address. Another, we have to find out the content of AC. So now we have to find out the immediate operand. What is the definition of immediate operand? It says that the address part itself works as the value of operand. So what will be the operand? 500 will be operand. Where will it be loaded? It will be loaded to AC. Why? Because the OP code is load to AC. It says that whatever the operand you have found, you have to load it to AC. So contents of AC will become as 500 and your effective address. Effective address is basically the target address where actually the operand lies. So iska target address, which one is the target address? It is 201. See, you can see that it is 201. So in case your instruction is immediate operand, value of effective address will be 201 and value of content of AC will be 500. This occurs in case the addressing mode is immediate operand. So while solving all these kind of the questions, you need to remember the definition of the addressing mode. As per the definition of the addressing mode, you need to find out the value of the effective address. And once you find out the value of the effective address, automatically you will get to know the value of operand. And then as per the nature of the given OP code, you have to apply that instruction in order to find out the final output value. Here, because we do have the load to AC, and that's why final output value we have to find out, which actually will be loaded to AC. The final operand value will be loaded to AC, that we have to find out. Now next we are going to talk about indirect address. Again, we have to go by its definition. What it says that first we need to go to address part. This is 500. 500 पे you need to go to 500. You will get the value of 800. 800 further will work as a value of address. You need to further have to search out for the value of 800 in the address portion. Ultimately, at the end of the memory, you found this 800, and at 800 location, you can view that the value of the operand is lying. So this 300 will work as the final value of the operand that will be loaded to AC, and where it is being stored, this 300 at the location 800. So this 800 will become as a value of effective address and 300 will become as the value of your AC. So ultimately, what will be answer? In case your instruction is indirect address, the effective address will be 800, wherever the content of AC will be 300. Fine. So these are the first three kinds of the addressing modes. Similarly, we approach to the next addressing mode, that is your relative address. What is the definition of the relative address? It says that address part is added to the value of the program counter for the next instruction. So we need to locate two values. One is address part, this 500 will be added to 202 in order to get the final effective address. So what will be the final effective address? It will be 500 plus 202. It will be 702. So now we need to search 702 throughout all these addresses. And ultimately, at this location, we find out the value of 702. 702 will become the final effective address. And at 702 location, we can view the value of the content is 325. So what will be the value of the AC now? It will be 325. This 325 will be loaded to AC. And what will be the address of this effective address? It will be 702. So in case your addressing mode is relative addressing mode. So in relative addressing mode, your effective address is 702, wherever the content of AC is 325. Now we switch to the next addressing mode. It is indexed addressing mode. Again, we have to go by its definition. index addressing mode, what it says that key the contents of index register are added to the address part of the instruction to find out the value of effective address. Here, if you view in the given information, here we do have three kinds of a register, 3 or 4 kinds of the register. Program counter consisting of initial value as 200. R1 is a general purpose register that is consisting of a value as 400, and XR stands for your index register that is consisting of the value of as 100. So as per the definition of index register, this 100 value is being added to the address part, that is your 500. 500 plus 100 will become as your 600, and 600 will become your effective address, and throughout the memory you need to search the value of the 600 under the addresses, and here we find out the value of 600, and at the 600 location we can view that value of operand is 900. So this 900 ultimately will be loaded to AC. So now what will be the value of AC ultimately after execution of the instruction? In case the addressing mode is index address, it will be 900. Wherever the value of index register, value of effective address will be 600. So in case of index register address, the effective address will be 600, wherever content of AC will be 900. Now we come to the next kind of addressing mode, that is your register addressing mode. Again we go by its definition. It says that in order to find out the final operand, the operand, basically we need to search the value of a register, and the register will consist of the value of the final operand. So here we can view that R1 register is given and it's consisting of the value as 400. So this 400 will become as a final value of the operand, but no address is specified in case of register. So here no value is given under the effective address field, but the value of operand that ultimately will be loaded in the accumulator register will be 400 in case the addressing mode is registered addressing mode. Now we switch to the next kind of addressing mode, that is register indirect mode. It says that first we reach to the, it's a similar kind of the previous addressing mode, the register mode we already have talked about. We need to come to the R1, and in R1 this 400 further will work as the address of the final operand in the memory. So we need to locate for this 400 in the under the address part of the memory, and at this 400 location we can view that this 700 is being stored. So this 700 will become ultimately the final value of the operand that will be loaded in the accumulator register, and this 400 will become as a effective address. So in case your addressing mode is register indirect, the value of effective address will be 400, wherever the content of AC will be 700. Now we switch to the auto increment. Auto increment is similar kind of the register indirect. It says that similarly first we need to go to R1, the value is 400. We need to go to the 400, the value is 700. 700 will become as the final value of the operand, and wherever the effective address will be same 400 as earlier we have talked about. But in case if subsequent instruction is being executed, in that case for the subsequent instruction this value of R1 will become as 401 in place of your 400. So it says that I'm going to repeat the value, the definition of the register indirect address. It says that it is similar to the register indirect address else the value of R1 is incremented once the value has been utilized. Once you have found the value of the effective address and the value of the operand, for the next instruction its value will become as a 401. For the present instruction, its value will be similar to the register indirect. It will not have any impact on the effective address and not on the value of the operand stored in the AC. So the value, if you can view that in case of register indirect and in case of auto increment, the effective address in both cases are same, and similarly content of AC in both cases are same. Now I come to auto decrement. First, I'm going to repeat the definition of the auto decrement. It says that the value of the register is being decremented by 1 before utilization of its value. Means its value is 400. Before we go to the location 400, its value is being decremented. So its value will become as 399. Fine. Now in place of searching the value of 400, we need to search for the value of 399 under the address portion of the memory. So under the address portion of the memory, we will be finding out the value of 399. 399 will become as the final value of the effective address, and at 399 we can find out the value of operand, that is 450. This 450 will be loaded in the accumulator register. What will be the value of AC now in this case? In auto decrement, it will be 450, wherever the value of address will be 399. So in case your auto decrement, effective address will be 399 and content of AC will be 450. So that's it for this lecture, for this in this session. But I'm going to give you the assignment from the back exercise based on this question. You have to solve some of the questions at your home, and in the next session we'll discuss all those doubts. Okay, clear?
Okay, ma'am. Same question I see.